What if reality is a quantum internet with no central server anywhere? In holographic informatics, the field contains many possible quantum states. Each state has a quantum state vector, or QSV, pointing in a direction. That vector carries orientation, phase, spin, frequency, and clock timing. Its angle tells us where the quantum state points within its geometry. As the phase angle turns, it creates a repeating internal quantum clock. The rate of that turning is omega, which means angular frequency. Omega is the change in phase angle divided by the change in ordinary time. So phase gives the clock position, while omega gives its ticking rate. The QSV angle also determines how a qubit projects into measured outcomes. The chance of 1 is sine squared of 1/2 of the angle called theta. The chance of 0 is cosine squared of 1/2 of that same theta. So probability can be understood as a projection of the quantum state vector. The same projection idea also explains components of light speed motion. Picture one velocity arrow moving at light speed in a chosen direction. Its x projection tells how much of that arrow points along the x-axis. That is light speed times the cosine of the direction angle called theta. Its y projection tells how much of the arrow points along the y-axis. That is light speed times the sine of the same direction angle theta. These are two projections of one motion, not two separate motions. Combine the x and y projections and the original vector is reconstructed. So the angle carries direction while changing phase also carries time. Now imagine that information being projected onto a black hole horizon. A black hole gives this information picture a real physical boundary. Its horizon separates different regions of space-time in a precise way. Black hole physics connects the area of that horizon with information. Hawking radiation gives the black hole a physical outward quantum process. In holographic informatics, the horizon acts like an information register. The QSVs supply changing angles, phases, frequencies, and spin states. Their interference forms holographic structure across that information surface. Think of a black hole as a spherical information block in the network. The horizon is its surface, while Hawking radiation provides an outward readout. The particle pair picture helps visualize how this process is often described. One partner falls inward while the escaping radiation travels outward. The deeper description comes from quantum fields in curved space-time. Now the quantum internet has signals, clocks, projections, and physical nodes, but information still needs an address telling it where and how to route. That is where the geodesic becomes the address in this information system. A geodesic is the natural path something follows through curved space-time. On flat geometry, it behaves like the straightest route between 2 points. When space-time curves, the natural route curves with the geometry around it. Motion along that route can also be tracked by a clock traveling with it. So, a geodesic joins geometry, direction, motion, timing, and routing. Entanglement supplies relationships between separated quantum systems. It connects their states without becoming a faster-than-light message cable. Interference determines which quantum amplitudes reinforce and which cancel. The geodesic supplies the route through the resulting local geometry. In holographic informatics, that geodesic becomes an information address. Frequency is like selecting the channel carrying information through a network. Phase supplies the timing that keeps different parts of the signal aligned. Spin identifies the state and helps determine its possible measurements. The measurement basis acts like the decoding key used to read that state. Together, these properties form something like a quantum internet address. Entanglement identifies which information nodes are related to one another. Interference determines which of those relationships become coherent. The geodesic tells the local system how that relationship is routed. Measurement opens the selected address and renders the local quantum result. That same architecture connects the information network with the human brain. Microtubules and tubulin dimers form organized structures inside neurons. In holographic informatics, they function as matched biological receivers. They read phase, frequency, spin, orientation, and interference structure. Their lattice reconstructs relationships carried within the incoming pattern. The brain acts less like a hard drive and more like a network receiver. It does not need the entire information field physically stored inside it. It needs the correct frequency, phase, address, timing, and decoding relation. One active geodesic can be pictured as one open information channel. Many channels can overlap while coherent phase relationships remain locked. Their integrated pattern produces one local conscious point of view. Change the geodesic address and different information becomes accessible. Change the phase relationships and the interference pathway changes with them. The field holds the possible quantum states and makes them available to them. Entanglement establishes the quantum relationships that connect them. Interference organizes those relationships by reinforcing or cancelling them. Black hole horizons provide physical information boundaries that organize them. Hawking radiation provides an outward quantum process associated with them. Geodesics provide the curved routes that give local addresses to them. Microtubules form biological receivers that read and reconstruct them. Measurement selects the local outcomes from the possibilities within them. In holographic informatics, conscious experience emerges by reading them. Together, those relationships render probability, gravity, motion, space, and time.